Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step 1. Identify the molecular formula and connectivity of each structure. Structure: a wedge-dash representation of a carbon chain. The central carbon bears H, CH3, CH3, and C2H5 as substituents, but a carbon can only have 4 bonds. Reading carefully, this is a sawhorse wedge-dash of a 2-carbon unit. The left carbon has H, wedge, H, CH3, dash, and is bonded to the right carbon which has CH3, C2H5, dash. This gives 3-methylpentane, CH3CH, CH3, CH2, CH2, CH3, or more precisely it depicts a specific conformation of 3-methylpentane. Actually rereading, the structure shows a single stereocenter with substituents H, CH3, C2H5, this is 2-methylbutane, isopentane, or a segment thereof. Most likely, A is a specific conformation of 3-methylpentane shown as a wedge-dash formula. Structure: B. Newman projection. Front carbon C2H5, H3C, H back carbon H, CH3. This represents a staggered or eclipsed conformation of 3-methylpentane, the C2-C3 bond Newman projection with ethyl and methyl groups. Structure: C wedge-dash with 2 CH3 groups on wedges and 2 CH3 groups on dashes and 1 H, this is 2,3-dimethylbutane with the central C to C bond shown, with each carbon bearing 2 methyls and 1 H. Structure: D sawhorse drawing with CH3 on front carbon and C2H5, H on back carbon, this is another conformation of 3-methylpentane. Structure: E Newman projection with CH3, CH3 on front and CH3, H3C, H on back. Front carbon has 2 methyls and 1 H. Back carbon has 2 methyls, H3C and CH3, and 1 H. This gives a carbon with substituents CH3 to CH on each side, which is 2,3-dimethylbutane. Step 2. Group by constitutional identity. Group 1, 3-methylpentane, C6H14, branched structures A, B, D, all appear to represent 3-methylpentane in different conformations representations. Group 2, 2,3-dimethylbutane, C6H14, different branching structures C and E, both represent 2,3-dimethylbutane. Step 3. Answer A, which are identical in all respects. C and E both are 2,3-dimethylbutane. Structure: C is a wedge-dash and E is a Newman projection of the same compound in the same configuration conformation, they represent identical molecules. B and D both are Newman projection and sawhorse of 3-methylpentane in the same conformation, they are identical representations of the same molecule in the same arrangement. Answer A, C and E, and B and D. Step 4. Answer B, which are conformational isomers? Conformational isomers have the same connectivity and configuration but differ only by rotation about single bonds. A and B are both 3-methylpentane but in different conformations, different Newman wedge-dash representations showing different rotational states. A and D are also both 3-methylpentane in different conformations. Answer B, A and B, or A and D. Step 5. Answer C, which are constitutional isomers? Constitutional isomers have the same molecular formula but different connectivity. 3-methylpentane A, B, D, and 2,3-dimethylbutane C, E are both C6H14 but with different carbon skeletons, So any pairing of one from each group gives constitutional isomers A and C, A and E, B and C, C and D, D and E. Answer C, A and C, or A and E, B and C, C and D, and D and E. Therefore, the correct answer is A, C and D, B and D, B, A and B, or A and D, C, A and C, or A and D, B and C, C and D, and D and E. The correct answer is shown on screen.